Okay, today we're going to be doing area of parallelograms and triangles. Everyone's tension back up here now. Right here. Eyes and ears right up here. Thank you. Area of parallelogram. How do we find the area of a parallelogram? Chase?
You make it into two triangles?
You could make it into two triangles. Yeah. Yeah, it might be a little easier to just deal with it as a base times height situation. Area is equal to base times height. Okay. Now you can think of it as two triangles. In fact, when we talk about triangles, that's what we'll cut that in half. Okay. So if I'm finding the area of a parallelogram, what I need to do is find the base. So if I'm looking at number 1 here, if I look at the length of the base, and you think of our base, I like to think of it as just the bottom portion there. So in this case, I'm going from, on the x-axis, I'm going from -4 all the way to 0, right? So that length right there is a length of 4. Okay, and zoom in on that. When I'm talking about height, height is a right angle height. So it goes from one side to the other at a right angle. So if you look at this and could kind of think of this right here as my height, because it hits this at a right angle right here. Okay, so that's my right angle height. Well, that's going from -5 on the y-axis all the way up to 3 on the x. So -5 to 3 gives me 8. Okay, so I have a base of 4 and a height of 8. So base times height is 32. And square units, if they don't give us an actual unit measure, we'll do square units. Bless you.
Yeah, thank you.
Any questions there? Not a ton to that. Hopefully that's a bit of a review. Did you guys try number 2 there? Give that one a go. Okay, so once again, if we're thinking area equals base times height, okay, in this case my base has a length of -3 to 3 or 6. I have a height of, it looks like -2 up to 4 or 6. So my area is 36. Okay. Any questions there? Well, here's a question. Could I have called this my height? Or my base, excuse me.
Yes.
Like if I turned it like that. It's harder to see it, right? I mean, it's harder to calculate that length there. But let's say I gave you a problem like this guy right here. This one says find x to the nearest 10th. Okay. And I have a figure dealing with this whole figure right here. Okay, I'm not worrying about any of that little triangle piece out there in terms of finding the area. The area of the figure I'm finding is this guy right here. That's pretty good coloring, I gotta say. I mean, I went out of the lines a little, but I haven't colored in a long time. All right. How many can find the area? Ignore the directions. So what if we just say find the area? Okay, what's the area?
32.
Everyone agrees 32?
Yes.
Base times height? Okay, base is 8. Height is 4. So area is equal to 8 times 4, which is 32. Okay, everyone agrees. Okay, let me turn it this way now. Now I have a slanted building, right? You know, the leaning tower. Okay. What's my base? Area equals base times height, or in this case 5 for my base. What's my height? It's a right angle height from this side to this side. Yeah. Yeah, it's x, right? Because we can't actually get a right angle to go in the figure. So we have to pretend like if you're a little dude hanging here. This is dangerous. Don't try this at home. Okay? And you're like holding a string. You're like, hey, other dude, catch the string. We'll measure this. Or, you know. Let me zoom in here so you can see the dude. All right, you guys see what I'm saying? Dangerous. We frown on doing this at home. Don't do that. Okay? But that's what you're doing. You're measuring your height. You're like, hey, drop me a tape measure and we'll figure it out. Okay? That's what's happening there. All right, so you're measuring how far off the ground you are. Okay? Dangerous, but this will give me my height. So my height is actually x. Everyone see that? Now the question that I have, does my area change when I'm looking at it this way than when I'm looking at it like this? Talk with your neighbor. Does it change if I go like this? Did the area of my building change? Okay, how many say, yep, it's changed? Nope, it hasn't changed. Same building, right? It's just there and there. Same building. All right, so what's the area? 32. So the area is 32. Right? How do we know that? Because we figured it out right here. So really what we're saying is 5 times x equals 32. How did we get the 32 again? What did we multiply? Base times height, which was 8 times 4. So really we can say 5 times x equals 8 times 4. Everyone see that? So 5x equals 32, or x equals 32 fifths, or 6.4. 6.4. Okay, you could leave it as 32 fifths as well. But any questions there? A bit different. I want you to try that one. Find x to the nearest tenth. My bad, same one. I meant to put that one up. Find x to the nearest tenth. That'll make. Yeah, I think so. Okay, find x to the nearest tenth there. Work with your partner. Once again, we are finding the area of this figure right here. That coloring was not as good. Unbelievable. I'm sorry. I know.
And you missed a few spots?
I know.
Yeah, like on G8. Send me back to kindergarten.
Yes, that would be good. Area equals base times height. I subbed in kindergarten once. That was the toughest. That was really tough. Man, you've seen Kindergarten Cop? That was me. That was not good. Holy moly. Okay, bases. In this picture?
15.
Nope. The way we have it sitting right now, I'm going to say the base is the thing it's sitting on.
7.
7. In relation to the 7, what line intersects it at a right angle?
X.
X. So area equals 7 times x. Now, if I turn this, and we look at it like that, now my base, in fact, I've actually rotated it here, but I'm going to turn it here so you guys can do the same. Now my base is 15. Okay, so if we're thinking area equals base times height, our height intersects our base at a right angle. So here's our base. What line intersects at a right angle? 6. So if area is equal to 15 times 6, and area equals 7 times x, then we could set those two things equal to each other and we know that 7x equals 15 times 6, or 7x equals 90, which means x equals 97, which is about 12.9 square meters. How many got it? These are a little tough. You've got to be able to rotate the figure and look at the two different, so this could be your base or this could be your base, but the area never changes. Okay? All right, any clarifying questions on that? Kind of weird. Ask your neighbor if they get it.
You get it? Yeah. But this one.
No, if they say no, let's explain it to them. And then I want you and your partner to turn and talk to the people behind you about it. Explain it to them. All right, done talking now. Any questions? Some good clarifying ones there. Logan?
Okay, so like on number 8, there's no height inside of the shape, kind of, so we can use the one on the outside where it's 11.
So on number 8, there's no height on the... Yeah, so when you're looking at your base, think of it this way. When you look at your base and you trace it, you need to find the line that hits that at a right angle. So in this case, 11.
So as long as it hits a right angle.
As long as it hits it at a right angle. So when you turn it and you look at the base this way, you're like, oh, there's the right angle, so that's x. So with this base, the height is x. With this base, the height is 11. Now, you guys, I emphasize this so much because this is very tough for students to grasp. You know, it's easy to just say, hey, this could be your base or this could be your base. But then understanding that the altitude, remember when we did altitudes with our note cards? The altitude that hits that side at a right angle is the corresponding height. So the height changes depending upon how you look at the base. Yeah?
Okay, so when we're finding the height, are we finding it for the dotted line of x, or are we finding it for the line that's...
You're looking at your right angle height, not your slant height.
Oh,
So this is your right angle height.
okay.
Yep.
But it's...
Okay, or
well, like, are we so when it's finding x, are we finding, like, the dotted line or the solid line, but it's just...
this x is this dashed line.
Oh, okay.
Yeah.
So I was going to say, I'm just like, we just put the height goes on bigger to x because it's like...
Can I what?
Well, okay, never mind, I'm just going to confuse myself. Never mind.
Okay. Yes, the x goes with the dashed line.
Okay.
Okay.
On the next one, it says find WB. Would X pretty much just be that line?
So on number 9, finding WB, that would be this line, yeah.
Okay.
Yep, that would be your height. That would be your height when looking at it this way. Right, with your height compared to this base. Okay, guys, I want to move on to triangles. Tell your neighbor how you find the area of a triangle.
Yes.
All right, time's up. What's the formula for area of a triangle? Grace? Good. Base times height divided by 2. And in fact, if I were to look at this figure right here, any triangle, if you duplicate that triangle, like if you take it, do some rotation or some slides or reflection, it depends. But in this case, if I move this triangle so that I lie it right next to itself, I end up making a parallelogram. Right? So no matter what triangle you have, if I were to just take and sketch any random triangle, any random triangle can always be made into a parallelogram. If I take that triangle right there, you can kind of see if I do this stuff to it, I can make a parallelogram out of it. Okay? Now, this right here, this portion, the actual triangle I had, is half, or excuse me, it's the same as this triangle up here. Now, if I were to sketch it, it makes it look a little better, but Okay, so my base and my height, now once again I'd have to deal with a right angle height here, which would be this height. Okay, but my base and height, if I multiply base times height and then cut it in half because I only want the half that was original, that gives me my area of the triangle. So if I'm looking at this one, if I say, well, this triangle right here is the same as this triangle up here, I probably could have done a better job at sketching it, but this is my base, this is my height. Okay, base times height gives me the area of my overall figure. I need to cut that in half then. Okay, base times height divided by 2. All right. So area of a triangle is equal to base times height cut in half. Now, how many have seen that formula before? How many have seen it like this? 1/2 base times height. The same formula, it's just multiplying by 1/2, same thing as dividing by 2. And generally we multiply by 1/2. Okay? So in this case, 7 times 4 cut in half. Now a quick trick for those of you that you're like, well, I can do that in my head or I can't do it in my head. When you're dealing with a fraction and you're multiplying it through, really you only have to take half of one of these two numbers. Which one's easiest to take half of?
4.
4. What's half of 4?
14.
14?
I mean 2.
Or 2.
Well,
2 times
2
7
hours.
is 14. Okay, now most of you would do that in your head. But if I made this 71, it's a little tougher to do in your head, right? 71 times 4 divided by 2. But if it was 71, and I said, well, find the area of that, you could take half of 4, which is 2, and double 71. Right? That would give you your answer of 142. Everyone see that? Okay. So with the 71, which we just changed, the answer is 142 square centimeters. Okay, or if I'm looking at, say, like number 10, area equals base times height times 1/2. 1/2 base times height. Well, I can put in my 9. I could put in my 5. Now, it's tough to take half of either of those. Okay, so I end up with a fraction here. 45 cut in half is 22.5 square meters. I want you to try that one without a calculator, please. Number 11, without a calculator. Okay, what did you take half of?
4.
Which one's the easiest, better one to take half of? Yeah.
I took half of 22 because it's 11.
Yeah, half of 22 is 11. 11 times 4 is?
44.
44.
Oh yeah, that would have been easier.
Yeah, if you take half of 4, then it's 2, and then you got to double it, but either way. 44 square inches. How many got it? Okay, a lot of formulas this chapter, guys. So, any questions on that?
Can we have a formula sheet on like a test?
Oh, I don't know about that. Seems like something that, I don't know. I have to talk to Mr. Vogel. You guys may have to convince him. Area of the shaded region. All right. These are not on your sheet. I know. So this is my shaded region. Okay. I want you to find the area. This whole thing's shaded on this one. I want you to find the area of the shaded region. Work with your partner, please.
Oh.
Any thoughts on the first one? How to find the area of the shaded region? Diamond?
So what did you find the area of the whole thing, which we got was 6?
Okay, so to find the area of the whole thing, you did base times height divided by 2. Okay, so 1/2 of 4 by 3, and you say that's 6. Okay.
And then we found the area of the unshaded region, which we got was 3.
Okay, so the unshaded area did 1/2 of 2 times 3.
Yeah.
And half of 2 is 1 times 3, so 3.
And then the difference between 6
subtract these, and you get, that gives you the area of shaded. All right, very good. Well done. So that gives us 3. It's 3 square feet. How many got 3? Okay.
Hey, yeah.
Good. So you really have to deal with different pieces, right? You kind of got to separate them, break them apart. So like on this one, a little tougher, right? How many see a triangle? How many see a parallelogram? The whole thing's shaded. Have to find the area of the whole thing. Okay? Work with your partner there. Try that guy there.
Shaded. Okay. It's at 20 because.
Okay, for those of you that may be struggling, here's how I'm thinking about it. You may be thinking about it differently, but I'm looking at it as 2 different shapes. Now, once again, my coloring is getting worse as we progress through class. All right.
That was okay.
Sorry. So my thought is if I can find the area of the parallelogram,
Oh my god.
That's what I think it is.
Oh.
I think I got this.
Oh, you did it.
and I add it to the area of the triangle, I can take it and find the total area. Area of the parallelogram is usually easy. It's base times height. So in this case, what's my base? 15. What's my height?
21.
21. Okay. What's the triangle area? What's the base of the triangle?
20.
Everyone agree it's 20? What's the height of the triangle?
21.
Yeah, it's still this height, right? It's the same height. Okay. So this height right here is also the height of the triangle, 21. And then we have to take 1/2 of that. So 15 times 21
Do 15. and
10 times, so half of 20 is 10 times 21 is 210. So grand total of 525.
Oh, I got it right. Man.
All right. How many got it?
Yeah.
We'll donate. Okay. Do we need to try another? We good?
Yeah.
Who wants to see another?
I want to see another.
It's kind of fun.
Who are
We should do
good?
another one.
I'm also good, but I still want to see
All right, we're done.
But
All right.
they're
I need
fun.
you guys, but just so that we're aware on this one, well, I think we need to be done with it. So, I want you guys to take a look at your assignment. You cross out the example side. We're going to do the mixed side. On the mixed side, number 16, the shaded region is this region right here. Okay?
No, it's the top and that
And
little
that
area, right?
Yeah.
Yeah.
That is the shaded region.
That's good coloring.
Thank you, man. Yeah. Come on, redeem it.
Ha! That was perfect.
Almost, yeah.
Almost. You have like
I don't want to
the little
brag.
top area.
Okay. All right. Why don't you take out Friday's assignment, please?